Welcome back, everyone. So, we will just go back to the design, the first chapter of interaction action design that uh, has unclear audio with a human to computer interaction video. So, these are the first chapter of interaction design book by Yvonne Rogers. So, let's start. Introduction. Think for a minute about how usable they are, how many are actually easy, effortless, and enjoyable to use. So think about the technology that we use, how effortless and enjoyable they are to use. Some like tablet are a joy to use, where tapping an app and flicking through photos is simple, smooth, and enjoyable. Others like buying a train ticket from a ticket machine that does not recognize your credit card after completing a number of steps and then makes you start again from scratch can be very frustrating. Why is there a difference? Alan Cooper, a well-known user experience guru, bemoans the fact that much of today's software suffer from the same interaction errors that were around 25 years ago. Why is this still the case, given that interaction design has been in existence for more than 30 years, and given that there are far more designers now in industry than ever before? He points out how many interfaces of new products do not adhere to the interaction design principles validated in the 1990s. For example, he notes that many apps do not follow even the most basic of user experience design principles, such as offering an undo option. He explains that it is inexplicable and unforgivable that these violations continue to resurface in new productions today. How can we rectify this situation so that the norm is that all new products are designed to provide good user experiences? To achieve this, we need to be able to understand how to reduce the negative aspects, such as frustrations and annoyance, while enhancing the positive ones, for example, enjoyment and efficacy. This entails developing interactive products that are easy to learn, effective, and pleasurable to use from a user perspective. We consider what is gain and loss from transforming activities to be digital when previously they were done through using physical artifacts. We then describe what and who is involved in the process of interaction design. So this chapter will be designed to, or will be explained from physical artifacts to now digital artifacts. So much of what we are doing that used to be physical before is now being done digitally. And then we will describe what and who is involved in the process of interaction design. Since about 2010, UX design has been most widely used terms in industry to refer to the profession. However, the terms have been used interchangeably. Also, it depends on each company's ethos and brand. Customer experience, on the other hand, refers to all of the interactions someone has with a company's offering, including the overall experience, the probability they will continue to use it, and the likelihood they will recommend it to others. In this sense, the UX is a part of the wider CX, but the CX covers other aspects that the UX has traditionally not covered. How to apply people-centered design. Spend years in the location. It's the only way to discover the true nature of the problem in an area and gather invaluable insights. Collaborate closely with the local populations, earn their trust, learn their language, and closely study what they show you about the world through their eyes. Many are creative and imaginative and understand their problem as well as their own capabilities and limitations. See everything as a system. Even the most simple looking problems are usually intricately intertwined. So aim past the symptoms, although symptoms still need treatment to get at the causes in the big picture. Co-design with your population, where the community drives things. You're more likely to do things that local people accept and achieve real change. Get these people on board, let them contribute to the research, ideation, prototyping, and production processes the solution involves. If they're invested in the solution like this, they'll feel ownership and be able to step in to fix things. If the population breaks or fails. or even improve it. Also, small and simple intervention works far better than grandiose, expensive big fixes. So these are the principles in design. Spend years, collaborate closely, see everything as a system, co-design with your population first to make them accountable, and then to create a system that will stand on your own without you. Also, a simple intervention such as simple change of cleanliness with people create this big change over time. So it's not the big things or the big change that is more fulfilling and long lasting in the end. It's the small changes of community. Keep an open eye on the solution the population has attempted themselves. Understand what people intended to do. If this were abandoned, learn why they failed. For example, was it the wrong technology? Did a natural disaster render them useless? So, keep an eye on the solution they have tried based on what they know. They usually have tried more than you can imagine. Remember that foreign can mean within your own country, province or state, or even city. Regional disparity can mean huge difference in quality of life over just a matter of a few miles. So a few miles could have different culture and different things or design are applicable to them. So this is what design make uh, 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 these are how design is so complicated because it's different for different people, for different places, even just a few miles. So what are the example of good and poor design? A central concern of interaction design is to develop interactive products that are usable. By this we mean products that are generally easy to learn, effective to use, and provide an enjoyable experience for the intended people. A good place to start thinking about how to design usable interactive products is to compare examples of well-designed and poorly designed ones. Through identifying the specific weakness and strengths of different interactive products, we can begin to understand what it means for something to be usable or not. Many viewers, especially when sitting in their living rooms, find it difficult to locate the right buttons, even for the simplest of tasks, such as pausing or finding the main menu. It can be especially frustrating for those who need to put or their reading glasses each time to read the button. The remote control appears to have been put together very much as an afterthought. So here is an example of bad design. How was it possible to create such usable and appealing remote device when so many others have failed? Sorry, it's an example of a good design. So best way to start to know what is a good or how design works is to look at a good and bad example of design. So the answer is simple. TiVo invested the time and effort to follow a people-centered design process. Specifically, TiVo's director of product design at that time involved potential users in the design process, getting their feedback on everything from the feel of the device in the hand to where best to place the batteries, making them easy to replace but not prone to falling out. They did this by restricting the number of control buttons embedded in the device to the essential one. Other functions were then represented as part of the menu option and dialog boxes displayed on the TV screen, which could then be selected via the core of physical control buttons. The result was a highly usable and pleasing device that has received much praise and numerous design awards. In many ways, the TV interface, which one consisted of simply choosing from among a few channels, has become more like a computer interface. This raises the question of whether the remote control is the best input device to use for someone who sits on a sofa or chair that is some distance from the TV screen. Smart TV developers have addressed this challenge in a number of ways. So this has been the ways of how the designers overcome this design problem. An early approach was to provide an on-screen keyboard and numeric keypad that presented a grid of alphanumeric characters. See figure 1.2a, which were selected by pressing a button repeatedly on a remote control. However, entering the name of a movie or an email address and password using this method can be painstakingly slow. It is also easy to overshoot and select the wrong letter or number when holding a button down or on the remote to reach a target character. Other systems have tried alternatives, such as different arrangement of the alphanumeric characters on screen using the numeral keys with their telephone-style associated letters, and sliding a small physical keyboard from the underside of the remote control. None of these has proven perfect. More recent controls, such as those provided by Apple TV, incorporate a touchpad to enable swiping, akin to the control commonly found on laptops. While this form of touch controls expedites skipping through a set of letters displayed on a TV screen, it does not make it any easier to type in an email address and password. Each letter, number, or special character has to be selected. Swiping is also prone to overshooting when aiming for a target letter, number, or character. Instead of providing a grid, the Apple TV interface displays two single lines of letters, numbers, and special characters to swipe across. While this can make it quicker for someone to reach a character, it's still tedious to select a sequence of characters in this way. For example, if you select a Y and the next letter is an A, you have to swipe all the way back to the beginning of the alphabet. Fire Stick TV has pared down the number of buttons on its remote controllers to a core set of basic navigation ones, up, down, needed to interact with its streaming media players. On recognizing the command, the Echo will switch on the TV, switch to the right HDMI channel, open Netflix, and begin streaming the specific episode. A recent survey found voice input is becoming ever more popular. 1 in 5 TV users now use voice input to find movies, shows, or videos, change the channels, change the volume, or turn the TV on or off. Also, if the TV needs the viewer to provide password to access on-demand content, they won't want to say it aloud, character by character, especially in front of others who might also be in the room with them. The use of biometrics then may be the answer. Switching to digital, so from physical to digital, instead of walking up to a machine and buying a ticket or an ATM to withdraw cash, many of us now do such transactions digitally using an app on our smartphone or tablet. Mostly, this has made the task easier, quicker, and more convenient. An example is being able to pay for parking via a mobile phone app. 20th century parking meters require drivers to insert coins to rent a parking space, which meant drivers wouldn't have the correct coins, couldn't legally park. Now, instead of fumbling around trying to find the right change for the time wanted and slotting this into a physical meter, we can fill an online form in advance with our details and pay each time we want to park using a credit card or digital pay app. Our details can then be stored ready for the next time we need to pay for parking, meaning even if fewer steps to complete subsequently. It just needs us to type in the parking location number where we plan to park, and the rest is filled for us by the app. Some apps will even notify us on our phone when the time we have paid for is nearly up, asking if we would like to add time. All we need to do is press a button from our phone. Not only does this form digital prompting prevent us from risking a fine if we exceed the time limit, but it also provides more revenue for the parking company. Many previous physical transactions have been digitalized like this. Other examples include buying tickets from an entertainment site like movie, concert, a play, or booking a ticket to go somewhere, train, a bus, an airline. An added benefit is not having to wait in line before being able to buy a physical ticket. The customer can also check various preferences for which kind of ticket they want, which can all be stored and accessed again at a later date. There are, however, disadvantages of switching over to digital. First, it requires a person to process a smartphone that is capable of downloading and storing the digital tickets. Second, some people still prefer to use older phones, which the apps won't work on, while others prefer to have paper-based tickets. Third, it can also be stressful and cumbersome to some people, especially if they do not have much battery power left on their phone, or they need to fumble around trying to find their glasses to see the apps on their phone. There is, of course, the option of printing out digital ticket onto paper, but that assumes someone has access to a printer. A further problem is if the person is entitled to a discount, like student, senior, disabled, it may require them to show a card in person to the ticket collector, which can mean having to switch between apps, which can be cumbersome. So as you can see, it presents the positive and downsides of switching to digital. So switching to digital may not be as the natural as having it do it naturally because of this small and seemingly uh, uh, inconsequential steps, like what if someone is student, senior, or disabled, and what if the phone is uh, not supported by the new app. That's why you need to like continuously learn this technology, because it will avoid you to have these downsides. People who are disabled using certain assistive technologies may be unable to use a digital ticket, which could lead to legal and ethical issues as well as emotional distress. Another disadvantage is that some people don't like to divulge their personal details online and would prefer to buy a ticket anonymously and pay by cash. So another thing is the inclusiveness, which is the design concept or principle. You need to be updated with that, as well as security. And security is continuously evolving the same way design is. So the only way to really adapt to this new world, which is the technological world, is to really be to really keep learning. So what to design? Design interactive products require considering who is going to be using them, how they are going to be used, and when and where they are going to be used. Another key concern is to understand the kind of activities people are doing when interacting with these products. The appropriateness of different kinds of interfaces and arrangement of input and output device depends on what kinds of activities are to be supported. Again, the interface and arrangement of input and output device depends on what kinds of activities are to be supported. And then, these products also depend on who are going to use them, how, and when, and where. So, you need to answer those detailed questions. Who, how, when, and where. Another key concern is to understand the kind of activities, which is what. For example, if the activity is to enable people to bank online, then an interface that is secure, trustworthy, and easy to navigate is essential. In addition, an interface that allows a customer to find out information about new services offered by their bank without it being intrusive would be useful. There are many types of interfaces and interactive devices available now, including multi-touch displays, speech-based systems, mobile device, and wearables. There are also many ways of redesigning how people can interact with them, for instance via the use of menus, commands, forms, icons, gestures, and so on. Ever more innovative everyday artifacts are being created using novel materials such as e-textiles. Wearable glasses that look like fashionable shades have also started to appear, such as snap spectacles that let the wearer experience augmented reality. Here's an example. More recently, smart supermarkets have appeared that do not require the shopper to even have to check out the goods they want to purchase. A sophisticated network of AI-enabled cameras in the ceiling, together with shelves embedded with weight sensors, can determine what a customer picks up and puts in their bag or pocket, billing them as soon as they leave the store. The smarts are in how the computer vision, sensor fusion, and deep learning are combined to track customers and what they took form or replaced on a shelf. Amazon Go pioneered this type of store, with other supermarkets now testing their own versions. So, the new smart instead of the smartphone is in how the computer vision, sensor, and deep learning are combined to create this amazing smart supermarket. The advent of Internet of Things, where data is collected from sensors and travels via the internet to other devices, has been embedded into several of our household products. For example, a popular household IoT-enabled products is home security, where people can keep an eye on their home from the data relayed to their smartphone via a combination of sensors placed in their home. So it could be hard to think of what to design and how to design this, because there's new technology emerging every single day. or every single hour. Now, it's good to know how these combinations are being done today, or research for an example of the choices available of how these new technologies are being done, such as this IoT in combination with AI, etc., or computer vision combined with sensors and deep learning. Some home-based security cameras also use machine learning that recognizes whether an intruder is trying to break into the house through using facial recognition. Machine learning is also being used in a range of other home products such as automated thermostats like the Nest, which optimize the temperature settings for a household where the algorithms analyze its energy consumption over time. Many decisions need to be made based on an understanding of people, including the following. Consider what people are good and bad at. Consider what might help people with the way they currently do things. Thinking through what might provide quality experiences. Considering a person's privacy concerns if data is being collected about them. Listening to what people want and getting them involved in the design. Using people-centered techniques during the design process. What is interaction design? By interaction design, we mean the following: designing interactive products to support the way people communicate and interact in their everyday and working lives. Put another way, it is about creating experiences that enhance and augment the way people work, communicate, and interact. More generally, Terry originally described it as designing spaces for human communication and interaction. So interaction design is basically knowing how people communicate and interact in their everyday and working lives, and then creating technology based on it, not based, not just creating technology. So it's about creating experiences, satisfying experiences that enhance and augment the cognitive ability of people in their everyday life. So it extends us rather than degrade us, which is what's happening really in the young people nowadays with this social media. The components of interaction design. We view interaction design as a fundamental to many disciplines, fields, and approaches that are concerned with researching and designing computer-based systems for people. It can be confusing to try to work out the differences between them as many overlap. The main differences between interaction design and the other approaches referred to in the figure come largely down to which methods, philosophies, and lenses they use to study, analyze, and design products. Another way they varies in terms of the scope and problem they address. So here, design principles, graphic, and then the new one is cybersecurity, data science, etc. For example, information system is concerned with the application of computing technology in domains such as business, health, and education, whereas ubiquitous computing is concerned with the design, development, and deployment of pervasive computing technologies, for example, IoT, and how they facilitate social interactions and human experiences. Since we created Figure 1.5, many other computer-related fields have emerged where the user is considered central. These include cybersecurity, digital humanities, data science, and digital healthcare. For some fields, there has also been shift toward being more people-centered, for example, human-centered AI. Would it make sense to add this, and if so, how? We could add a further section that identifies where interaction design has informed other fields. For example, those where software tools have been developed for scientists, researchers, clinicians to use as a part of their methodology. These include the built environment, bioinformatics, medicine, marketing, computational biology, and computational design. We could also try to add a number of other fields and practices that have begun to inform interaction design, including behavioral economics, ethics, accessibility, and AI. Now, who is involved in interaction design? So here we answer what is interaction design. So it comprises of many fields. It's a lot of interaction field that communicates. That's why it's complex adaptive system. So who is involved here? Designers need to know many different things about people, technologies, and interactions among them to create effective experiences. At the least, they need to understand how people act and react to events and how they communicate and interact with each other. To be able to create engaging experiences, They also need to understand how emotions work, what is meant by aesthetics, desirability, and the role of narrative in human experience. So, not just knowing that how people currently do their everyday life and trying to augment their capabilities, you also need to know facts about them, such as what is the current psychological research or facts about what they're good at and bad at. So you need to understand how people act and react to events and how they communicate and interact with each other. To be able to create engaging experiences, they also need to understand how emotion works, what is meant by aesthetics, desirability, and the role of narrative in human experience. So it's also the role of stories on how we perceive the information, how we make sense the information, how is the balance of aesthetic and functionality be applied in our product. So they also need to understand the business side, technical side, manufacturing side, and marketing side. Recently, there has been more emphasis on understanding the ethical aspects, specifically for technologies that are collecting ever increasing amounts of personal data, such as smart speakers and personal healthcare devices. Questions raised include how do we ensure the new technology or product is safe, secure, perceived to be trustworthy, and valued and understandable by the general public. Clearly, it is difficult for one person to be well versed in all these diverse areas and also know how to apply the different forms of knowledge to the process of interaction design. Interaction design is ideally carried out by multidisciplinary teams because of the triangulation, which we will discuss later. But knowing this will allow you to avoid isolation and bias, because most often for designers, their number one big issue is themselves. So if you know triangulation, and then if you're willing to ask for other perspective, then you're on the right path. So um, so here, how to apply the different forms of knowledge to the process of interaction design. Interaction ideally carried out by multidisciplinary teams where the skill sets of engineers, designers, programmers, psychologists, anthropologists, sociologists, marketing people, artists, toy makers, product managers, and others are drawn upon. One of the benefits of bringing together people with different backgrounds and training is the potential of many more ideas being generated, new methods developed, and more creative and original designs being produced. So, going back here, it comprised of different people and how people live. And here, as we can see, we design an IoT. Where is that? On the question of what to design, there is like an IoT device for things that is available. So people don't know the extent of their choices usually. So we don't know what we don't know, or we don't know the choices that's available. So what triangulation do is that it allows you to extend your capability or the limits of your own experiences, and then ask for other experiences and what is the available options for them. So these are the key in being creative and asking for available options. So here, new methods develop and more creative and original designs being produced. However, the downsides is the cost involved. The more people there are with different backgrounds in a design team, the more difficult it can be to communicate and make progress with the design being generated. Why? People with different backgrounds have different perspectives and way of seeing and talking about the world. What one person values as important, others may not even see. Similarly, a computer scientist's understanding of the term representation is often very different from that of a graphic designer, media specialist, or psychologist. What this means in practice is that confusion, misunderstanding, and communication breakdown can surface in a team. So this is a big problem: confusion, misunderstanding, and communication breakdown. So take note of this. These are the basic problem that people encounter when trying to design or create new things. Because you're trying to generate as much idea, it's inherent that you will be confused. That's why there's no one design framework, because it's different for different circumstances. The various team members may have different ways of talking about design and may use the same terms to mean quite different things. Other problems can arise when a group of people who have not previously worked as a team are thrown together. So these are the reason why design is a growing field, and also it requires you to continuously learn. So it's a good field that does not rely on one framework or research. That's why if you research how to be good in design, there's a lot of books, or there's no like one standard that systemize what design is, because it's different for different circumstances. Kind of like a cybersecurity, where it requires you to learn different fraud trends or different kind of hacks that is being created by people due to the nature of complex adaptive systems. For example, Aruna in 2011 found that integration across different disciplines and expertise is difficult in many projects, especially when it comes to agreeing and sharing tasks. The more disparate the team members in terms of culture, background, and organizational structures, the more complex this is likely to be. Ideally, so what makes things complicated is this: different people, different cultures, different beliefs. That's why it's also important to read complex classic fiction, so that you understand that your experience is not the only experience in this world. Ideally, each team will have a number of different people with different skill sets. For example, the first interactive product would include the following individuals: graphic and interaction designers, museum curators, educational advisors, software engineers, software designers, and ergonomists. The second project would include these types of individuals: TV producers, graphic and interaction designer, teachers, screenwriters, information architects, UX researchers, video experts, software engineers, and software designers. Interaction design consultancies, marketing departments focus on how the branding. So there is also interaction design consultancies that basically do the UX for you. Marketing departments focus on how the branding, the number of engagement, the customer return rate, and customer satisfaction are greatly affected by the usability of a website. So these are the parallel or related jobs in UX. The marketing departments that focus on branding, the number of engagement, customer return rate, and customer satisfaction. So those are related in sales. Many now have their own toolkits for testing the different aspects of a website. For example, using A/B testing to determine the effect of different UI designs on metrics such as sales or the numbers of repeat visitors. Financial services, retail, government, marketing, video, and film producers, and the public sectors have realized its value too. The presence or absence of good interaction design can make or break a company. Getting noticed in the highly competitive field of smartphone apps requires standing out. Being able to demonstrate that your product is easy, effective, and engaging to use is seen as central to this. Smaller consultancies such as Bannyfoot promote diversity, interdisciplinarity, scientific research, having psychologists, researchers, interaction designers, usability, and customer experience specialists on board. People-centered design. People-centered design involves understanding people, how people feel about a product, and their pleasure and satisfaction when using it, looking at it, holding it, and opening or closing it. So it is centered on people, in you, not on mysterious or new technology. It includes their overall impressions of how good it is to use, right down to the sensual effect small details have on them, such as how smoothly a switch rotates, or the sound of a click and the touch of a button when pressing it. As Don Norman in 2004 stresses earlier, it's not enough that we build products that function, that are understandable and usable. We also need to build joy and excitement, pleasure, and fun, and yes, beauty to people's lives. Apple's realized early on that successful interaction design involves creating interactive products that provide not just usable but also enjoyable experiences. The sleek appearance of the iPad music player, its simplicity of use, its elegance in style, its distinct family of rainbow colors, a novel interaction style that many people discovered was a sheer pleasure to learn and use. And the catchy naming of its product and content, iTunes, iPad, among many other design features, led to its becoming one of the greatest products of its kind and a must-have fashion item for teenagers, students, and adults alike. While there were many competing players on the market at the time, some with more powerful functionality, others that were cheaper and easier to use, or still others with big screens, more memory, and so forth. The quality of the overall experience paled in comparison to that product by the iPad. In addition, Apple provided a whole ecosystem that accompanied the iPad, including the iTunes Store app, where millions of licensed music tracks could be bought for less than $1 each. So, people-centered design is about creating, also about sales. Okay, it's not the most technological or most innovative product wins, but the most people-centered. So, what would you do with an innovative product if people don't want to use it? Apple has continued to design products that are both beautiful and usable. Most notable are the iPad and the range of iPhones. It even designed what was at the time a completely new customer experience for buying technology in the form of the Apple Store, from how it draws people in and what they do when browsing, discovering, and purchasing goods in the store. There are no checkouts to pay for goods, just roaming Apple employees holding a mobile device that they interact with to make an order for a customer, take payment, and email them a receipt. So as you can see, guys, it kind of like sort of become a government where it determines or create a new way of buying and selling. Therefore, it was integrated in people's life, and then it allowed them to get a recurring revenue, just like government for recurring taxes. So I know it's kind of like bad metaphor, but I just want to emphasize that a difference as well. Small details like that will help us remember this, because this small understanding of designing for people. So it's not the most innovative products or most technology advanced, but it's those people centered that could integrate in people's life, that are easy to use, and satisfying, comfortable, because we resist, we we are a creature of habit. We always go in the path of least resistance. So you need to capitalize on that psychology. There are many aspects of the user that can be considered, in many ways of taking them into account when designing interactive products. Of central importance are the usability, functionality, aesthetics, content, look and feel, and emotional appeal. In addition, Jack stresses other wide-reaching aspects including fun, health, social capital, the social resources that develop and maintain through social networks, shared values, goals, and norms, and cultural identity such as age, ethnicity, race, disability, family status, occupation, and education. So, sort of, it makes it like a natural or how we live in the real world. So, the more you can mimic the naturality of how we live in the real world, because in real world we also have this as well. We need to determine or consider the factor of social capital, the health, and ethnicity, race, disability, family status, occupation, and education. So how does one go about designing quality experiences for people? There is no secret source or magical formula that can be readily applied by interaction designers. However, there are numerous conceptual frameworks, tried and tested design methods, guidelines, and relevant research findings, which are described throughout the book. So there's no secret source that can be applied to all interaction design. However, there are conceptual frameworks that we have discussed in the previous video, which are different in different scenarios. There's also guidelines for us to keep grounded or where we can start our further research that are described throughout the book. So you can think of that as the basics or the principles. So understanding people, a collaborative planning tool for space mission intended to be used by teams of scientists working in different parts of the world will have a quite different needs from one target at a customer and sales agent to be used in a furniture store to draw up kitchen layout plans. Understanding individual differences can also help designers appreciate that one size does not fit all. What works for one group of people may be totally inappropriate for another. For example, children have different expectations than adults about how they want to learn or play. So these are like all people bias. So now we're digging deep on understanding what people is. So here we describe the importance of people-centered design. So what is really people? People are basically us, but since we are different and we are only on our own when doing our thing, it's hard or it's unnatural for us to be able to empathize to others on what it is really like to be them. So there is understanding of different tools or different products are applicable for different people, and different truths are also applicable to different people. They may find having interactive quizzes and characters help them along to be highly motivating, whereas most adults find them annoying. Teenagers also enjoy short videos such as the ones they watch and uploaded to TikTok and YouTube. Conversely, adults often like a podcast discussion about topics which children and teenagers find boring, just as everyday objects like clothes, food, and games are designed differently for children, teenager, and adults. So too should interactive products be designed for different kinds of people. Learning more about people and what they can do also reveal incorrect assumptions that designer may have about particular groups and what they need. For example, it is often assumed that because of deteriorating vision and dexterity, older people want things to be big, be it text or graphical elements appearing on a screen, or the physical controls like dials and switches used to control devices. This may be true for some old people, but studies have shown that many people in their 70s, 80s, and older are perfectly capable of interacting with standardized information and even small interfaces, for example, smartphones, just as well as those in their teens and 20s, even though initially some might think they will find it difficult. It is increasingly the case that as people get older, they do not like to consider themselves as getting older. Associated with lacking in cognitive and manual skills, being aware of people's sensitivities such as aging is as important as knowing how to design for their capabilities. In particular, while many older adults now feel comfortable with and use a range of technologies, for instance, email, online shopping, and online games or social media, they may resist adopting new technologies. So, although people now use this and adapt to these new technologies, they may resist it. So, for that is the one of the known psychology for older people, and they want it big, the icons, etc. This is not because they don't perceive them as being useful to their lives, but because they don't want to waste their time getting caught up by the distractions that digital life brings. So they also don't want the distraction. For example, not wanting to be glued to one's mobile phone, like younger generations. Also, some of them are just not technology. They're just not good in technology. They're bad at it. So instead of like wasting their last 5 years in this earth learning that thing, they will just enjoy it. So being aware of cultural difference is also an important concern for interaction design, particularly for products intended for a diverse range of groups from different countries. Why is it that certain products like a fitness tracker are universally accepted by people from all parts of the world, whereas websites are designed differently and reacted to differently by people from different cultures? How does the design and use of social media platforms differ across cultures, such as Weibo and Twitter? The former is used primarily in China by more than 500 million people, whereas the latter is used worldwide by more than 200 million people. So as you can see, different culture, different use of technology. Accessibility and inclusiveness. Inclusiveness being fair, open, and equal to everyone. Inclusive design is an overarching approach where designers strive to make their products and services accommodate the widest possible number of people. An example is ensuring that smartphones are being designed for all and made available to everyone, regardless of their disability, education, age, or inco- income. Inability to use a product can result because technologies are often designed in such a way as to necessitate a certain type of interaction that is impossible for someone with a disability. So, sometimes the technology are not designed for those disabled people. Such an inability is viewed as the result of poor interaction design between a person and the technology, not the impairment alone. Technologies that are now mainstream once started out as a solution to accessibility challenge. For example, SMS was designed for hearing impaired people before it became a mainstream technology. Furthermore, designing for accessibility inherently results in inclusive design for all. Accessibility can be achieved in two ways. First, through the inclusive design of technology, and second, through the design of assistive technology. When designing for accessibility, it is essential to understand the types of impairments that can lead to disability, as they come in many forms. They're often classified by the type of impairment, for example, sensory impairment, such as loss of vision or hearing, physical impairment, having loss of functions to one or more parts of the body, for example, after a stroke or signal cord injury, cognitive, for instance, learning impairment, or loss of memory, cognitive function, due to conditions such as Alzheimer's. So here, I'll provide a mnemonics, which is SPC. Okay, sensory, physical, cognitive. So these are the types of accessibility. With each type is a complex mix of people and capabilities. For example, a person might have only peripheral vision, be colorblind, or have no light perception, and be registered blind. All are forms of visual impairment and all require different design approaches. Color blindness can be overcome by an inclusive design approach. Designers can choose colors that will appear as separate colors to everyone. However, peripheral vision loss or complete blindness will often need an assistive technology to be designed. Permanent, for example, long-term wheelchair user, temporary, such as after an accident or illness, and then situational, for instance, noisy environment means a person can hear. So here, PTS maybe, or STP, whatever things that is, you already know. But permanent, I think that's easy to understand. Temporary, this situational are the most unique. So these are the things that, or the things that you, I mean, that you want to remember or to like hold in your mind right now. The number of people living with permanent disability increases with age. Fewer than 20% of people are born with a disability, whereas 80% of people will have disability once they reach 85. As people age, their functional abilities diminish. For example, as people get older, they find it more difficult to hear conversation in rooms with hard surfaces and lots of background noise. So this is a good information or statistics. So most of us will have a disability by age 85. So it's important to be empathetic with those disabled people because you'll become like that in time. You know? And also, one of the things that are most likely to went off with our senses or hearing senses. So yeah, here is an example of situational, permanent disability, usability and experience goals. So these are the basics. Part of the process of understanding people is to be clear about the primary objective of developing an interactive product for them. So part of people is their objective. What are their purpose in life? Like what do they want? What do they want to achieve? Is it to design an efficient system that will allow them to be highly productive in their work? Is it to design a learning tool that will be challenging and motivating? Or is it something else? To help identify the objectives, we suggest classifying them in terms of usability and experience goals. Usability goals are typically stated as questions. The purpose is to provide the interaction designer with a concrete means of assessing various concepts, aspects of an interactive product and the user experience. However, simply asking, is the system easy to learn, it's not going to be very helpful. Asking about the usability of a product in a more detailed way, for example, how long will it take someone to figure out how to use the most basic functions for a new smartphone? How much can they capitalize on from their prior experience, and how long would it take them to learn the whole set of functions will elicit far more useful information. Usability goals. Traditionally, usability goals are concerned with meeting specific usability criteria such as efficiency, whereas user experience goals are concerned with expanding the nature of the user experience, for instance, to be aesthetically pleasing. It is important to note, however, that the distinction between the two types of goal is not clear-cut, since usability is often fundamental to the quality of the user experience, and conversely, aspects of the user experience such as how it feels and looks are inextricably linked how usable the product is. So traditionally, these goals are for only usability criteria such as efficiency, whereas the experience are concerned with explicating the nature of the user experience, for instance, to be aesthetically pleasing. However, this efficiency could mean different for different people. Sorry, this efficiency are intricately connected to the usability. So it's like in the prototype to validate test, it's kind of like hard to differentiate where is the prototype categorized, where it is highly interconnected to the validate phase. So effectiveness is a general goal, and it refers to how good the product is at doing what it's supposed to do. Question: is the product capable of allowing people to carry out their work efficiently, access the information that they need, or buy the good that they want? So it's like an overall experience, or how overall satisfied is the customer. Efficiency refers to the way a product supports people in carrying out their tasks. So it's more detailed, more focused on their task, individual task, on that whole experience. The example mentioned earlier of buying tickets online using stored personal details on the app is considered efficient. Once the people have entered all of the necessary personal details in an online form to make a purchase, they can let the website or app save all of their personal details. Then if they want to make another purchase at the site, they don't have to re-enter all of their personal details. A highly successful mechanism presented by Amazon is the one-click option, which requires people to click only a single button when they want to make another purchase. Question: how many steps does it take to complete a task? How does storing a personal details make it more efficient? So this task, seemingly inconsequential to the effectiveness, which is the first parameter, is actually made the experience better, or enormously better. So those are one of the critical tasks and features that makes this product efficient. Safety involves protecting a person from dangerous conditions and undesirable situations. In relation to the first ergonomic aspect, it refers to the external condition where people work, for example, where there are hazardous conditions such as X-ray machines or toxic chemicals. Operators should be able to interact with and control computer-based systems remotely. So, here you're also thinking about how safe it is. The second aspect refers to helping anyone in kind of situation to avoid the designers of carrying out unwanted actions accidentally. So here is where some of the design are inherently harmful, or some of the design are not built on security in mind. That's why you have this a lot of accident and security issues, because it was not the designer that created this does not have an experience with security or accident related jobs. It also refers to the perceived fears that someone might have of the consequences of making errors and how this affects their behavior. Making interactive products safer in the sense involves 1. Preventing the user from making serious errors by reducing the risk of wrong keys or buttons being mistakenly activated. Example is not placing the quit or delete file command right next to the save command on a menu. And 2. Providing people with various means of recovery should they make errors, such as an undo function Safe interactive system should engender confidence and give people the opportunity to explore the interface to try new operations. Another safety mechanism is confirming dialog boxes that give users another chance to consider their intention. A well-known example is the appearance of a dialog box after issuing the command to delete everything in the trash, saying, "Are you sure you want to remove the items in the trash permanently?" Question: what is the range of errors that are possible using the product, and what measures are are there to permit someone to recover easy from them? Utility refers to the extent to which the product provides the right kind of functionality so that users do what they want to do. Another thing that I would add is that there are many ways to solve what is the customer's goal. So here's where the functionality comes. Is this the best functionality to use that? It may work now, or it may be what the customer are using with their app, but is it the best one? Is it the most efficient? Is it the most effective? Is it the most safe? Right? So all of these are interconnected. An example of a product with high utility is an accounting software package that provides a powerful computational tool that accountants can use to work out tax returns. An example of a product with low utility is a software drawing tool that does not allow users to draw freehand but forces them to use a mouse to create their drawings using only polygon shapes. So these are the extreme. Like, you created a product to solve this particular function, but you end up not really solving this product. So it creates a bad user experience. Question: does the product provide an appropriate set of functions that will enable them to carry out all their tasks the way they want them to do? So it's not just about aesthetics or making these things efficient or beautiful. It's also providing them the actual functionality that they want. So that contributes to user experience overall, and all of that is interconnected. Learnability refers to how easy a product is easy to learn. Generally, people want to get started right away and become competent at carrying out basic tasks without too much effort. This is true for interactive products intended for everyday use, for example, social media, and those used only infrequently, for instance, online tax forms. Learning may continue over the lifetime of someone's interaction with a product, so that basic use of eventually becomes mastery. To a certain extent, people are prepared to spend a longer time learning more complex systems that provide a wider range of functionality, such as web authoring tools. In these situations, pop-up tutorials can help by providing contextualized step-by-step material with hands-on experiences. So these are where the balance of this functionality or hard learnability will be effective, because for like in games, you want an expert to have this advanced functionality, while the beginners are should be able to learn it fast. So you need to balance and know exactly your user. And again, it's different for different contexts. A key concern is determining how much time someone is prepared to spend learning a product. Question: is it possible to work out the basic use of the product by exploring the interface and trying certain actions? How hard will it be to master the product in this way? Are additional learning tools needed? Memorability refers to how easy a product is to remember how to use once learned. This is especially important for task and interactive products that are used infrequently. So these are particular measure or user experience goals for products that are not used frequently, which often your product is not like that. If someone hasn't used an operation for a few months or longer, they should be able to remember, or at least rapidly be reminded how to use it. They shouldn't have to keep learning how to carry out tasks. Unfortunately, this tends to happen when the operations required to be learned are obscure, illogical, or poorly sequenced. People need to be helped to remember how to do tasks. There are many ways of designing the interaction to support this. Another thing is that the more functionality we want, or the more like technology advance we get, the more complex things are. But the issue is like, how do you balance, or how you make that advanced or complex? We want to be complex, but at the same time, we want to have an easy or memorable things. Just like when trying to create an app. So I'm just surprised how can't this Node, or when I try to create a Node app, why can't the Node 20 be applied on our thesis? So those are the things. And also I need to like enter a command, legacy command, etc., which has like a really poor, I can't remember those commands, so I need to type it down. So those are the things that you need to know with your users. So for example, users can be helped to remember same place on the screen, help user remember where to look to find a particular tool at a given stage of a task. So one of the useful psychology to remember is, when like dealing with this, is the recognize and search. So the more you can make the function recognizable instead of them searching it, the better it is. So question, what types of interface supports have been provided to help someone remember how to carry out tasks, especially for ones they use infrequently? Satisfaction generally refers to how acceptable a product is when being used. It is most often used to measure a customer's experience. Various satisfaction scales have been developed for this purpose. For example, asking customers to give a score from 1 to 5 to indicate how satisfied they are using a product. So it's also, here I want to provide a caveat that it also depends on how you present the questions. So we've discussed this in the previous video, so I would recommend watching that. But for satisfaction as well, if you like, these are interconnected as well, because the more effective the product is, the more people will be satisfied. But that's not the satisfaction part. It measures not just the effectiveness, but the people's answer to the survey on the last part and how it presented it. It also includes the function. As you can see, this is so interconnected. The most well-known one is called, question, what are the mean, median, and mode values on the CSAT scale? What proportion of users say they are highly satisfied with the product? How many people are still satisfied after using the product for 6 months? Examples of commonly used usability criteria are time to complete a task, efficiency. So again, time is efficiency. Time to learn a task, learnability, and the number of errors made when carrying out a given task over time, memorability. This can provide quantitative indicators of the extent to which productivity has increased or how work, training, or learning have been improved. User experience goals. Many of the these are subjective qualities and are concerned with how a system feels to someone. They differ from the more objective usability goals in that they are concerned with how people experience an interactive product from their perspective, rather than assessing how useful or productive a system is from its own perspective. So again, from the user perspective, kind of like the satisfaction, it defines how you present it and how the people currently are feeling, or how the people was interpreting it currently. So here is the user experience goals. So here, usability goals. Here, user experience goals. Satisfying, enjoyable, engaging, pleasurable, exciting, entertaining, helpful, motivating, challenging, enhancing social ability, supporting creativity, cognitive, stimulating, fun, provocative, surprising, rewarding, emotionally fulfilling, experiencing flow, undesirable aspects, boring, frustrating, making one feel guilty, annoying, childish, unpleasant, patronizing, making one feel stupid, cutesy, gimmicky, creepy, intrusive, invasive, deceptive, annoying. They also overlap of what they are referring to. In so doing, they offer subtly different options for expressing the way an experience varies for the same activity over time, technology, and place. For example, we may describe listening to music in the shower as highly pleasurable, but consider it more apt to describe listening to music in the car as enjoyable. Similarly, listening to music on a high-end, powerful music system may evoke exciting, emotionally fulfilling feelings, while listening to it on smartphone that a subtle shuffle mode may be serendipitously enjoyable, especially not knowing what tune is next. The process of selecting terms that best convey a person's feelings, state of being, emotion, sensation, and so forth when using or interacting with a product at a given time and place can help designer understand the multifaceted and challenging nature of the user experience. The concepts can be further defined in terms of elements that contribute to making a user experience pleasurable, fun, exciting, and so on. They include attention, pace, play, interactivity, conscious and unconscious control, style of narrative, and flow. The concept of flow in 1997 continues to be popular in interaction design for informing the design of user experiences for websites, video games, and other interactive products. It refers to a state of intense emotional involvement that comes from being completely involved in an activity like playing music and where time flies. Instead of designing website to cater to visitors who know what they want, they can be designed to induce a state of flow, leading the visitor to some unexpected place where they become completely absorbed. The quality of the user experience may also be affected by a single actions performed at an interface. For example, people can get much pleasure from turning a knob that has a perfect level of gliding resistance. They may enjoy flicking their finger from the bottom of a smartphone screen to reveal a new menu, with the effect that it appears by magic, or enjoy the sound of a trash being emptied from the trash can on a screen. These one-off actions can be performed infrequently or several times a day, which the person never tires of doing. Dunn, in 2014, has described this as micro-interaction and argues that designing these moments of interaction at the interface, despite being small, can have a big impact on the user experience. Some combinations will also be compatible. For example, it may not be possible or desirable to design a process control system that is both safe and fun. Recognizing and understanding the nature of the relationship between usability and experience goal is central to interaction design. So you have to do the trade-off. So sometimes it's really not possible because of the nature of this contradicting phenomena, which is, it's not that contradicting, but some products or some circumstances just have contradicting phenomena that allows you to make choices. So that's a different for different circumstances. So it enables designer to become aware of the consequences of pursuing different combinations when designing products and highlighting potential trade-offs and conflicts, as suggested by Jack in 2004. Articulating the interaction of the various components of the user experience can lead to a deeper, more significant interpretation of the role of each component. Eric argued that we should be focusing more on the user experience and less on usability. He pointed out how many websites are designed to persuade or influence rather than enable people to perform their tasks in an efficient manner. So, for persuading, that's on the usability goals without people. But for asking people what they want, it's helping them in their efficient manner. So that's Eric's argument. For example, many online shopping sites are in the business of selling services and products where a core strategy is to entice people to buy what they might not have thought they needed. So I think it's also related to how system thinking and user-focused design are different as well, because for some circumstances you want to think about the systems on the overall usability goals, not just what the user perspective, because you also need to consider other parts of the system. But for user focused goals, I think we have discussed that in the previous videos. You're only focusing on what the user said and what will make them satisfied on the task, but not everything that the user wants or what make them do their task faster will also help the system as a whole. So sometimes there's a contradicting motivation, such as insecurity. Not all of the things that are convenient are also less secure. So you have to balance that. Online shopping experience are increasingly about persuading people to buy rather than being designed to make shopping easy. This involves designing for persuasion, emotion, and trust, which may not be compatible with usability goals. Many online travel sites try to lure visitors to purchase additional items such as hotels, insurance, car rental, car parking, or day trips besides they originally wanted to book, and they will add a list full of tempting graphics to the visitor's booking form, which then has to be scrolled through before being able to complete the transactions. These opportunities need to be designed to be eye-catching and enjoyable, in the same way that an array of products are attractively laid out in aisle of a grocery store that one is required to walk past before reaching one's desired product. Some online sites, however, have gone too far. For example, adding items to the customer's shopping basket, for example, insurance, special delivery, and care handling, that the shopper has to deselect if not desired or start all over again. This sneaky add-on approach can often result in a negative experience. More generally, this deceptive approach is known as dark patterns, a term first coined by Harry. Many sites go to great lengths to make it difficult for you to leave. You think you have unsubscribed, but then you discover that you need to type in your email and click several more buttons to reaffirm that you really want to quit. Then, just when you think you are safe, I think we have discussed that, to the stop. Design principles. Design principles are used by interaction designers and to aid their thinking when designing for the user experience. These are generalizable abstractions intended to orient designers toward thinking about different aspects of their designs. So to help them, go back to the basics, these are the principles they go back to. But just these principles are not the be all and all, because it has its pros and cons. So the designers still need to tailor it on their own framework or circumstance. Design principles are derived from a mix of a theory-based knowledge, experience, and common sense. So again, it's based on experience. Because again, in design, you're mimicking your natural human way and experience to how would you apply it in your product, or in if you're creating a digital product in digital world. Visibility. Visibility refers to how an interface is designed to show what someone needs to do next to progress with their task. Don, in 1998, describes the controls of a car to emphasize this point. The controls for different operations are clearly visible, such as indicators, headlights, horn, and hazard warning lights, indicating what can be done. The relationship between the way the controls have been positioned in the car and what they do made it easy for the driver to find appropriate controls for the task at hand. Newer electric cars, however, have been designed so that the controls are activated from a touch screen next to the steering wheel. While easier to design and update from an engineering perspective, it can make it harder for the driver to know where to find them. So, for the engineers who can create this function, it's easy to use this, but it's easy to create this, but for the user, it's not. So, in contrast, when functions are out of sight, it makes them more difficult to find and to know how to use. For example, devices and environments that have become automated through the use of sensor technology, usually for hygiene and energy saving reasons, like faucets, elevators, and lights, can sometimes be more difficult for people to know how to control, especially how to activate or deactivate them. This can result in people getting caught short and frustrated. It does not explain, however, what to do if you're wearing black clothing. Increasingly high valuable controlling devices such as knobs, buttons, and switches, which are intuitive to use, have been replaced by invisible and ambiguous activating zones where people have to guess where to move their hands, bodies, or feet, or into or in front of to make them work. So again, this came basically, it is interconnected to our previous video about senses, where our highest energy or senses are in our visual senses. So it leveraging this principle. Feedback are related to the concept of visibility is feedback. This is best illustrated by an analogy to what everyday life would be like without it. Imagine trying to play a guitar, slice bread using a knife, or write using a pen. If not of the actions produce any effects for several seconds, there would be an unbearable delay before the music was produced, the bread was cut, or the words appeared on the paper, making it almost impossible for a person to continue with the next strum, cut, or stroke. So these are where the senses came. So without our senses in the world, without our eye determining which object would kill us, or without hearing any like cars that could hit us, it's really hard for us to survive in this world. So it's kind of like providing us this human gift, or you could say like powerful sense that allow us to like do this amazing things. Now, various kinds of feedback are available for interaction design: audio, tactile, verbal, visual, and combination of these. Deciding which combination are appropriate for different types of activities and interactivities is central. Using feedback in the right way can also provide the necessary visibility for user interaction. So, visual is like the superhighway of our perception, while this tactile, verbal, visual, smelling are like as a crowded street or um, crowded street. So basically, that is the difference of our senses. So you need to choose appropriately. If you can't really integrate the visual, then you can use this other senses. Constraints: there are various ways that this can be achieved. A common design practice in graphical user interface is to deactivate certain menu options by shading them gray, thereby restricting which actions are permissible at the stage of the activity. One of the advantage of this form of constraint is that it prevents incorrect options being selected and thereby reduces the chance of making a mistake. So these are indirectly or interrelated to the principle of salient information and attentions. So the more we can remove this unnecessary things, because we can only focus, our memory can only focus one at a time. So if we could remove the unnecessary or irrelevant things if by constraining it, then we are on the right path. The use of the different kinds of graphical information can also constrain a person's interpretation of a problem or information space. For example, flowchart diagrams show which objects are related to which, thereby constraining the way that the information can be perceived. The physical design of a device can also constrain how it is used. For example, most door locks are designed to allow keys to be inserted one way only. Consistency: this refers to designing interfaces to have similar operations and use similar elements for achieving similar tasks. In particular, a consistent interface, one that follows rules such as using the same operations to select all objects. For example, a consistent operation is using the same input action to highlight any graphical object on the interface, such as always clicking on the left mouse button. So it's like kind of the principle of making it as natural as possible with our senses, with our human way of making sense. Because like we are human, we need to look at it in human perspective. Inconsistent interface, on the other hand, allow exception to rule. An example is where certain graphical objects, for example, email messages presented in a table, can be highlighted only by using the right mouse button, while all other operations are highlighted using the left mouse button. The problem with this kind of inconsistency is that it is quite arbitrary, making it difficult for users to remember and making its use more prone to mistakes. Interfaces, especially when many different operations need to be designed. For example, consider how to design an interface for an application that offers hundreds of operations, such as wood processing application. There is simply not enough space for 1,000 buttons, each of which maps to an individual operation. Even if there were, it would be extremely difficult and time-consuming for someone to search through all of them to find the desired operation. A much more effective design solution is to create categories of commands that can be mapped into subset of operations that can be displayed at the interface, for instance via menus. This solution is both consistent and highly learnable. Affordance: this is a term used to refer to an attribute of an object that allows people to know how to use it. For example, a mouse button invites pushing, and so doing activating clicking. By the way, it is physically constrained in its plastic shell. So what principle of design is this related to the affordance? It could be recognizing by making it easy or obvious. Another thing is that there is this thing on our eyes. I forgot what it says, but there is like some colors or some patterns of the design or some differences in the objects that we see physically made it more likely for us to remember it. I will show you that in the next video, but basically that is the principle, because our eyes just does remember some differentiator more than others. So the some form of, it's kind of like in salient information video where the structure or the font makes a huge difference on how we are able to find the information. So as you can see guys, the affordance and then the recognizing, the consistency, all have this like different words, but it is interrelated to this salient information. But you know, the difference is very small. At simple level, to afford means to give a clue. When the affordance of a physical object are perceptually obvious, it is easy to know how to interact with it. For example, a door handle affords pulling, a cup handle affords grasping, and a mouse button affords pushing. The term has since much popularized in interaction design, being used to describe how interfaces should make it obvious as to what can be done and when using them. For example, graphical elements like buttons, icons, links, and scroll bars are discussed with respect to how to make it appear obvious how they should be used. Icons should be designed to afford clicking, scroll bars to afford moving up and downs, and buttons to afford pushing. Don Norman in 1999 suggests that there are two kinds of affordances, perceived and real. Physical objects are said to have real affordance, like grasping, that are perceptually obvious and do not have to be learned. In contrast, user interfaces that are screen-based or virtual and do not have these kinds of real affordance. Alternatively, screen-based interfaces are better conceptualized as perceived affordance, which are essentially learned conventions. However, watching a 1-year-old swiping smartphone screens, zooming in and out an image with their finger and tab, and touching menu options suggests that kind of learning comes naturally. So, since the children are able to do this zoom out in this screen interfaces, those kind of tasks suggest that it is a natural or could be a real affordance, but there's a small difference. So as you can see, small difference are important in interaction design. Many designers try to cram too much into a screen full of space, making it unwieldy for people to find the information in which they are interested. Removing design elements to see what can be discarded without affecting the overall function of the website can be a salutary lesson. Unnecessary icons, buttons, boxes, lines, graphics, shading, and text can be stripped, leaving a cleaner, crisper, and easier to navigate website. So just because you provided color on this amazing or any amazing technology you might think of doesn't mean it's people-centered. However, graphics, shading, coloring, branding, and formatting can make a site aesthetically pleasing and enjoyable to use. Good interaction design involves getting the right balance between aesthetic appeal and the optimal amount and kind of information with how the people will use it. So it depends really on the goals of the people using that product. Find an everyday handheld device, for example, a remote control or smartwatch, and examine how it has been designed, paying particular attention to how a user is meant to interact with it. From your first impression, write down what is good and bad about the way the device works. Give a description of the user experience resulting from interacting with it. Outline some of the core micro-interactions that are supported by it. Are they pleasurable, easy, and obvious? Based on your reading of this chapter and any other material you have come across about interaction design, compile a set of usability and user experience goals that you think will be most relevant in evaluating the device. Decide which are the most important ones and explain why. Translate each of your sets of usability and user experience goals into 2 or 3 specific questions. Then use them to assess how well your device fares. Repeat steps 3 and 4, but this time use design principles outlined in the chapter. Finally, discuss possible improvements to the interface based on the answers obtained in steps 4 and 5. Key points: discovering bad design is an opportunity for improvement. Always pair the bad news with a recommendation for what to do next. Interaction design is concerned with designing interactive products to support the way people communicate and interact in their everyday lives and working lives. Interaction design is multidisciplinary, involving many inputs from wide-ranging disciplines and fields. There's a growing shift toward replacing the term user-centered design with people-centered design. Optimizing the interaction between people and interactive products require consideration of a number of interdependent factors, including context of use, types of activity, design goals, accessibility, cultural differences, and user groups. Identifying and specifying relevant usability and user experience goals can help lead to the design of good interactive products. Design principles such as feedback and simplicity are useful heuristics for informing, analyzing, and evaluating aspects of an interactive product. Again guys, thank you for watching. See you on the next video. Peace.